Hello everyone, this is Rahul Shrestha here to present you the 7th part of the chapter Matter for class 8. So in our last class, we understood how in atoms of different elements, the electrons are distributed across the various cells of the atoms. We also read the rule, which is the 2n square rule, which help us determine how many electrons will be possessed by each cells. Now the topic of our class today is molecules. If you look at the definition, molecule is the smallest particle of a substance or matter which can exist independently. Now, in order to understand this properly, we need to get back in time to the video where I explained to you about atoms. According to the definition given in your books, it is the smallest particle of an element which can take part in a chemical reaction. For now, you leave this definition aside, as I'll get back to this at the later part of our chapter. So it was this later part of the chapter where I'll be discussing this definition of atom. So the definition tells us that atoms are the smallest particle of a matter that can take part in a chemical reaction. Here, what you need to understand is that in both these definitions of atom as well as molecule, it tells us that both of these are the smallest particle of a substance. So which one is true? Which one of the two is the smallest? Is it the atom or is it the molecule? See, in reality, an atom is generally smaller than a molecule for most of the substances. As molecules themselves are made up of one or more atoms, they are basically a group of atoms stuck together. A single water molecule contains 3 atoms. A single sugar molecule is made up of 24 different atoms in a special arrangement of hydrogen, carbon and oxygen atoms. A single fatty acid molecule contains 38 atoms, and a single protein molecule can contain up to 500 million atoms depending upon its type. So now we know that atoms in general are smaller than a molecule. But then these definitions also tell us that atoms can take part in a chemical reaction while molecules can exist independently. So let's try and understand what this actually means. See, basically there is a single word which is the reason for everything. And this simple word, if you would believe my words, is the ultimate reason behind the existence of every ounce of matter in this universe. It is the reason behind every single living creature of our planet or otherwise, and is also the reason behind every single phenomena that ever occurs. And this simple word is stability. Every single thing that exists, whether living or non-living, is in the form in which they are, looks the way they look, and behave the way they behave is all because of stability. And stability is nothing but the state of being calm, a state of no worries. See, if I talk about us human beings, we too want stability in our life. Stability in education, stability in money, stability with our family, with our friends, stable mentally without any tension, and stable physically without any disease. And this stability is also the demand and need of everything else as well. And this is also true for something as small as a single atom. If I talk about the smallest of all atoms, the hydrogen atom, this tiny little atom also requires stability. And for achieving this, it does something very incredible. Something which led to the creation of this whole universe, or rather all the different types of matter in the universe. What it did was, it bonded. It reacted with other atom to form a bond which provided both of these unstable atoms the stability that they required so earnestly. And this ultimately led to the formation of a hydrogen molecule, which basically was just a combination of these two atoms. So the fact is that most of the atoms of the elements by themselves are unstable. And in order to attain a stable state, these unstable atoms need to attain a state of either duplet or a state of octet. If the atom has a single shell, then the stable state is achieved by having 2 electrons in it, and this is called as duplet. And if the atoms have 2 or more shells, then the stable state is achieved when the outermost shell contains 8 electrons, and this is what is an octet. Atoms of certain elements like helium, neon, argon, etc. are already stable. These elements are called as noble gases or inert gases, as they do not react with other elements and are already stable, having 2 or 8 electrons in their valence shell. Now, valence shell is the outermost shell of any atom. Like if you look at this hydrogen and helium atoms, for both of these atoms, the valence shell is this first shell, which is the only shell that they possess. In the same manner, for these atoms of lithium and beryllium, this second shell is the valence shell, which is their outermost shell. And then the rest of the atom, which is the nucleus, and this first cell is the core of their atoms. Remember, the core of an atom never change, or you can also say that they never take part in a chemical reaction. Rather, it is the valence shell or the valence electrons which take part in any chemical reaction. It is only this valence shell and the electrons which are inside them, also known as valence electrons, which take part in chemical reactions and which is also responsible for providing the aforementioned stability to these atoms. And this is true for all the other elements as well. So what happens is that a single lone hydrogen atom has only 1 electron in its valence shell, and this is not a duplet state, which means it is not stable, and in order to get this stability it requires to form duplet, that is 1 more electron in its valence shell. So when another lone hydrogen atom comes into its proximity, which by the way is also in search for stability, they come together and form a bond by sharing their own electrons with one another like this, and this is how they gain stability. If you look closely at this structure, you will see that both these individual atoms, because of them sharing their electrons with each other, finally in this state has 2 electrons each in their valence shell. This atom has 2 electrons, as well as this one also has 2 electrons. And as they both have 2 valence electrons now in this state, they become stable. And then they settle down in this state independently without having the need for any further reactions, and this independent state of stability in which both of these atoms are currently at is the molecular stable state. Now coming back to our definition. So an atom is that smallest particle which takes part in a chemical reaction. And as we saw earlier with our lone hydrogen atom, because it was not in a stable state of duplet, it had the tendency to react with other atoms, which it did and hence gained stability. And this is what is meant by can take part in a chemical reaction. And then a molecule is that smallest particle of a substance that can exist independently. So in the case of the hydrogen molecule, after attaining this stable molecular state, both these atoms do not need to react with any other atoms anymore, as they are already stable, and so they can exist independently without needing to depend on any other further reaction. And this is why the statement, the molecules can exist independently. One last thing. Is it necessary that one hydrogen atom will always react with another hydrogen atom? The answer, of course, is no. Sometimes they also react with atoms of other elements and form different types of molecules of different compounds, like this water molecule or this methane molecule or this ammonia molecule. In all of these molecular states, you will always find that each one of the constituent atoms have either attained duplet, like these hydrogen atoms here. Each one of them has 2 electrons each in the valence shell. And then some of them may attain an octet state, like this oxygen, carbon and nitrogen atom each has 8 electrons in their valence shell forming octet. Now in each one of these examples, every single atom, in order to gain a stable state, are sharing electrons forming a bond called as covalent bond. But sometimes atoms, instead of sharing electrons, can also give and take electrons. Like in the case of common salt or sodium chloride, a sodium atom has 1 electron in its valence shell and a chlorine atom has 7 electrons. So what they do is, this sodium atom donates 1 electron to this chlorine atom, completely losing its true valence shell, which was this third shell, and then forms an octet state with this second shell, which now becomes its new valence shell, which already has an octet formed. In the same manner, chlorine atom, on gaining 1 electron, completes its octet and becomes stable as well. And this giving and taking of electrons between these two atoms give rise to a different type of bond known as the ionic bond. You will read in detail about the different types of bonds in your 9th class, but for now, this was all that I wanted to share with you people about atoms and molecules. We'll meet again one last time more in our last video of this chapter. I'm done with today's class. Until next time, take care and be safe. Thank you.